All right, I'm done with all my given information. So I'm just going to change color just so that I know. I'm done with the given stuff. I was only given these two things, and I took stuff away from it. And that's what's marked in the diagram. Now, I'm working on side angle side. Side angle side congruence is what I know. Okay, so I need a side, an angle, and a side. I have a side, the single marking. I have a second side, the double marking. I need the angle that's included in between them. That means I need to prove that angle ACB is congruent to angle ECD. And I know that they're vertical angles. Angle ACB is vertical to... Actually, I'm not going to say that. Sorry, I decided I'm going to do angle ACB is congruent to angle ECD, and that's because of vertical angles. Because they're vertical angles. I know that they're vertical angles, which means now I've got this angle in between. And I can say that these two triangles, which is what I'm trying to prove, my red point is that triangle ABC is congruent to triangle EDC by side angle side. Okay. There's only one proof on your thing. It's just I really wanted to introduce you to proofs and show you how to set up a proof. So each statement has to have a reason. I told you this. C is the midpoint because I was given it. It was told to me at the very beginning. I told you this because I know that midpoints split things in half, which means both sides are congruent. I told you this, again, because it's given. I told you this because I know midpoints split things in half. I told you this statement because those two angles are vertical angles. I can tell that from the picture. And I told you this because of side angle side congruence. Okay. All right. So let me do some quick examples, and I want you to think, are they side angle side or not? And I'll go over the answer in a minute, but I'm just going to draw a few diagrams, and then you're going to write yes or no. Okay, so there are 3 examples here. Your try it is to just pause this for a second and think about it. Do you think that I could prove that they are side angle side? Could I add something that any of these diagrams that would show side angle side? Take a minute, pause this video, and do that. Okay, hopefully you've come back. So let's start with the yellow one. Can I prove that there's side angle side? Well, let's look at this. In this triangle, both of the triangles share this line right here. I'm going to call it AB. They share AB, which means that they are congruent right there. So now all of a sudden I have side angle side congruence. Side angle side congruence. So this one works because I've got that line in between. Okay? All right, let's try the second one, this light bluish green one. So similarly to the first one, I know that they share this line right here. I'm just going to call it DE. They share DE, which means that that's congruent. I know that the triangle on the right has a 90-degree marked, and I know that that bottom line is a straight line, which means that I know that this is also 90 degrees. Okay? But if I look at this order of this, I actually only have side angle. I do not have an included angle, which means this is not side angle side. I cannot use side angle side for that one. Okay. All right, last but not least, this purple one. So this one is kind of tricky. It's got parallel lines. So we actually have to remember back to when we talked about parallel lines and parallel line theorems. So if I have parallel lines, if I extended these parallel lines, then I have created actually angles right here. An angle here and an angle here. And they're alternate interior angles. Alt-interior angles, which means they're congruent. Okay, and then I also have this line from here to here. Let's call it KL. And it is the same on both triangles, so it's congruent to itself. And now I have side angle side. That one I understand if you didn't get because it takes a lot to remember about parallel lines. But good job. There we go. Those are the 3 records there. Nice job.